when you saw a problem like this before, you would end up coming to the conclusion that there was no solution. But the real answer was that there were no real solutions. There is, however, an imaginary solution, a way that you can express the solution using imaginary numbers, specifically the imaginary number I. So, what you want to do when you're solving a quadratic equation is if you can get the square root, the x squared term by itself and no other x values anywhere, you can use the square root property to solve these quadratic equations. So we essentially want to undo the x squared by taking the square root of both sides, because the square root of x squared is x. So on number 6, what we would do is we would write the square root of both sides. If you take the square root of both sides, something happens to the variable that gives you two possibilities. If you take the square root of a variable that's being squared, there are really two possible solutions. It's going to be plus or minus x. The reason is because even if x was negative, when you square it, you could still get the same number as you do when x is positive. On the right side of this equation, we're going to break down the square root of negative 81 the way you just learned how with imaginary radicals. We could rewrite this as the square root of negative 1 times the square root of 81. Now recall that the square root of negative 1 is an imaginary number. It is the imaginary number I. Square root of 81 is just 9, so it's I times 9 equals plus or minus x. Well, that plus or minus sign could be applied to the right side, and you just leave x the same. So you could write this as x equals plus or minus 9i. So this means there are two possible solutions you could put in for x to make this equation true. Plus 9i and minus 9i. If you want to write both of these solutions separately, you could write x equals positive 9i and x equals negative 9i. Now, I will accept both solutions because both are correct. You could write both of the x values separately, like they are in this box, or you could write x equals plus or minus 9i. These mean the same thing. They're just written a little bit differently with the plus or minus signs. Let's go ahead and try to solve number 7. The first step in solving using the square root property is to get the x squared term by itself. So we need to get that 75 out of there. The way to do that is to subtract 75 from both sides. So now we have 3x squared equals negative 75. That x squared isn't quite by itself yet, so we want to divide both sides by 3. Now we've got a problem that's set up very similar to number 6. We've got an x squared on one side, and we've got a number on the other. What you want to do is take the square root of both sides. On the left, you're now going to have plus or minus x equals, well, let's break down the square root of negative 25. We'll pull out the negative part and get the square root of negative 1. And what's left is a positive square root of 25. So our answer is going to be, at this point, plus or minus 5i, because that square root of negative 1 turns into I, and the square root of 25 is 5. But we don't want to write it this way. We want to get x by itself. So essentially, we can write this as x equals plus or minus 5i. And that's the solution. If you were to plug 5i back in for x, you would find that if you add that number, square it, take it times 3, add 75, you would get 0. Number 8 is very similar to number 6. The x squared term's already by itself, so we're ready to take the square root of both sides. When we do that, you get plus or minus x equals the square root of -1 times the square root of 36. You keep going and you're going to get x equals plus or minus 6i. Number 9 has a situation that's more akin to number 7, meaning we need to do a little work to get x squared by itself. So we're going to subtract 48 from both sides. And we have x squared equals -48. Take the square root of both sides. So you're going to have plus or minus x equals the square root of -1 times the square root of 48. So we have plus or minus x equals I times, well, let's break down the square root of 48 a little bit more. We can find perfect squares that divide into 48. Preferably, we find the biggest perfect square that goes into 48 to simplify it the fastest. So perfect squares are things like 4, 9, 16, 25, 36, 49, etc. The biggest perfect square that goes into 48 is 16. So we could write this as the square root of 16 times the square root of 3. We picked a perfect square because we know what the square root of a perfect square is. The square root of 16 is 4. So the final answer is x equals plus or minus 4i times the square root of 3. Let's check one of these to see if it really works, to see why this is actually the solution. So let's go ahead and plug in one of the solutions, positive 4i times the square root of 3 in for x on number 9. So we're going to check our answer to prove that it really is right. So number 9 says it's x squared plus 48. So we got to square our solution. So it's going to be 4i times the square root of 3 squared plus 48 equals 0. So if this works out, we know we have the right answer. Well, 4i times the square root of 3 squared is the same thing as 4 squared times I squared times the square root of 3 squared plus 48 equals 0. So let's keep going. 4 squared is 16. Do you remember what I squared is? You probably haven't seen this yet. It's actually on the next part. But I'll tell you, I squared is the same thing as -1. The square root of 3 squared is just 3 plus 48 equals 0. And if you keep going, you're going to figure out that 0 equals 0, so this solution works. You can do the same thing with the other solution. The other solution was -4i times the square root of 3. If you plug that back in, it will also work as a solution. Let's take a look at number 10. On this problem, there's two things we have to do to try to get x squared by itself. We need to first subtract 25 from both sides. So you have 9x squared equals -25. And then the last step is you need to divide by 9. So we'll divide by 9. So now we have x squared equals -25 over 9. Using the square root property, we can take the square root of both sides to try to get x by itself. So you're going to have plus or minus x equals, well, this would be like the square root of -25 divided by the square root of 9, which equals the square root of -1 times the square root of 25, divided by, well, the square root of 9 is just 3. So we have x equals plus or minus 5i over